Slope of a graph. When you finish watching this video, you should be able to tell me what is the slope of a graph, how is the slope determined, and realize that the units of slope can be all sorts. What I have here is a graph drawn based on this data set right here. We're comparing data x and y. The way I have this drawn is I've chosen to put the y data, the y data on the vertical axes and the x data on the horizontal axes. That's what we usually do. And I've taken all the data pairs. 2, 1 is a data pair, 4, 2 is a data pair, 6, 3 is a data pair. And I've plotted the dots, and I've connected the dots with a smooth line. Now, it just so happens this data right here is linear. It forms a straight line. So that's the word linear. I've also plotted the graph on this set of axes. This is the same data. Now, definition of slope, the most common one is steepness. The slope is the steepness and direction of a line. And that's an okay definition, but it can also be misleading. And as you can see with these two graphs, same data. I just altered the, stretched out the graph on top, graph A, and you see that this appears to be steeper. So if you just take a first glance of one graph versus the other, you would say that, oh, well, this is steeper, so it has a steeper slope. And that's not the case. These two slopes are identical. So we calculate the slope. A and B appear different, but the slope is the same. Now, one last thing. If you look at the way I've plotted the data here, y is considered to be the dependent variable and x is the independent variable. The standard in science is such that we always plot the dependent on the vertical versus the independent on the horizontal. That's a standard. That doesn't mean it's always like that. There could be a reason why someone may want to flip-flop those two. But unless you have a particular reason, that's the standard that we stick to. And the way we interpret this is we say that y is dependent upon x. So when we draw a y versus x graph, y depends on whatever is happening on the x. I increase x, it looks like y is increasing also at a particular rate. That rate is the slope. Let's go to the next one. A better definition, slope is the ratio of a change in x, delta x, and the change in y, delta y. Delta, Greek letter delta, is a small little triangle. And in math and science, we consider that to be the symbol for change. Delta y, change in y. So what I've done is I've replotted the data again. Squashed the graph a little bit. Why? Because I needed to fit it on my board. That's why we alter the size of the graph, just because we want to make it bigger and we want to make it smaller. I've identified 2 points on this graph. That's important for you to calculate what that ratio is. I'm going to compare these two data sets, or data pairs. So slope is the ratio between y and x, or delta y and delta x. We commonly say that it's the ratio of the rise over the run. And what that means, if you look at the line rises and it also runs away from the axes. So we're comparing the rise of the y with respect to the run of the x, and it's still that ratio. Slope symbolized with the letter m. The way we figure out the change is we look at final minus initial of the y divided by final minus initial of the x. So data point A would represent 2, 1, and data point B would represent 8, 4. What we're going to do is A, 2, 1, 8, 4. Slope is equal to the change in y divided by the change in b. Change in y in this case will be 4 minus 1. What does that mean? Well, final y, initial y. So the y, on the y-axis, we went up from 1 to 4. So 4 minus 1 is 3. And on the x-axis, we started off at 2, and we went all the way up to 8. That's the delta x. So there'd be 8 minus 2. So that ratio simplifies to 3 over 6, or 0.5. So the slope, m, is equal to 0.5. Now we can pick any data points, any two data pairs, to figure out the slope on this line. And what I've done here is, there are a couple examples. I've picked this one right here, and looks like this one right here. So these two right here. So on the y-axis, the run is 5 minus 2. On the x, 10 minus 4. 5 minus 2 divided by 10 minus 4. Another set of data, we have going from this to this, these two data points right here, 4 minus 2 divided by 8 minus 4. And that also gives you 0.5. And then there's a third example there. So any two pairs of data in your data set can be used to figure out the slope of the line. Math is cool. So what about units of slope? Well, units depend upon the variables that you compare. When you do a study, it's always best to compare one variable to the other. You never compare 5 things at the same time, because if there's a change, it's very difficult to figure out what's causing the change. So we compare one axis versus the other axes. I want you to understand that variables are not always y and x. As teachers, we usually introduce graphing using y and x, but I want you to understand there are a lot more examples than just y and x. That's just the beginning. It's not very interesting either. So here's an example of mass versus volume. So the units of slope would be grams per milliliter, and that has a positive slope. Another example, distance, comparing distance versus time. How far does an object travel with respect to time? So the units would be meters per second. Here we have a negative slope, so something is decreasing. Volume is decreasing as pressure increases, and the slope would be liters per atmosphere. Here we have a study, number of mosquito versus number of bats. So the slope would be positive, and the slope units would be mosquitoes per bat. And here we have happy dreams versus purple monsters. So looks like we have a decrease here, and it's an exponential decrease, or an inverse relationship also. And we would have happy dreams over purple monsters would be the slope units. And lastly here, I love this because it represents physics class, the reward versus the effort. As you increase the effort, it looks like the reward increases exponentially. And you can see that because the slope of the instantaneous spots there are increasing.